We've said a couple of times in class that there are multiple kinds of radicals. We've dealt with a square root radical, which is the sign telling us to find the number that multiplied by itself equals the radicand. But there are also cube root, fourth root, and you could go even beyond that. So we use that letter n to stand for any root. So if b squared equals a, b is a square root of a. If b to the third equals a, then we say b is the cube root of a. If b to the fourth equals a, then we say that b is a fourth root of a, and so forth. And so whatever that nth root is, we write that as what's called an index, a smaller letter that sits out on top of your radical sign. A is a real number, and n is the index of the radical. So that would be the positive nth root of a. If we want the negative nth root, we would use the negative sign out in front. So as an example, if we were to try to find the fourth root of 81, that would look like this. I'm going to write my 4 as an index out in front of my radical and 81 on the inside. Now my question is, what number can I multiply by itself 4 times that's going to equal 81? And so let's start by thinking about, is there a number that, if I square it, gives me 81? And I recognize that 9 squared is 81. So now I'm thinking about this. What number times itself equals 9? And obviously that's 3. So the fourth root of 81 is 3. And in fact, positive and negative 3, because if I put negative 3 to the fourth power, I also get 81. Let's take a look here. Now I want the fifth root of negative 32. All right. So now I'm thinking about, is there a number that I can multiply by itself 5 times that gives me negative 32? And you might be saying, Mr. Dahl, you said if there's a negative inside the radical that we don't have a number that can do that. So now remember, that only works when I'm multiplying a number by itself. So 2 factors, right? Negative times negative is going to be positive. Positive times positive is going to be positive. But now I have 5 factors. So I'm going to have an odd number of either negative or positive factors. So yes, this is definitely possible to have a negative number when I have an odd index. So what number times itself 5 times gives me 32? And so here I just kind of have to work myself backwards. And so I know that 2 squared is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the fifth is 32. So now I know it's negative 2 to the fifth power equals negative 32. So negative 2 is the nth root, the fifth root of negative 32. Solving equations now. Now I'm trying to get the variable term by itself. Here I have 2x to the fourth. I'm going to divide both sides by 2. So x to the fourth now equals 81. Well, we just did that problem above here. So we can see that x equals plus or minus 3. In our next example, 6x to the third equals 384. So I'm going to divide both sides here by 6. If I go 6 into 384, you can tap that into your calculator quickly. And you get 64. So x to the third power equals 64. So I need a number that times itself 3 times, gives me 64. And again, I have to do a little guessing and checking. So 2 to the third is 8. 3 to the third, 3 times 3, 9 times 3 is 27. Let's try 4. So 4 times 4 is 16, times 4 again is 64. So x equals 4. We've got some experience in being able to operate with exponential expressions, variables raised to exponents. What happens when we multiply powers at the same base, divide powers at the same base, and so forth. And we found that we could add or subtract the exponents. What if we wanted to rewrite these radicals as exponents? And it turns out that we can, and we can use fractions to do it. We call those rational exponents. So the square root of 3 we could rewrite as 3 to the 1/2 power. This is like saying 3 to the first and then taking the square root of that. If I'm looking at this one, the third root with a cube root of 7. That's 7 to the first power, and I'm taking the third root. And so whatever that index is, that would be the denominator of my fraction. So taking a look at some examples. 9 to the 1/2 power, that's the same as saying takes the square root of 9, so that's 3. 64 to the 1/3, that's the cube root of 64, just like we had in our example equation. Is it possible that we could have no solution on these? Well, sure. An even root of a negative number does not have a solution in the set of real numbers. So negative 32, I don't have a number I could multiply by itself 4 times. It's going to give me a negative, so that has no real solution. The real power here is that we can combine our powers and our roots in one expression now. So here's a case where we have 2 as our radicand. We want to take the cube root of that and raise the result to the 4th power. So we have 2 to the 1/3 power, that's what our index tells us, and we're raising that to the 4th, so multiplying a power to a power, we multiply exponents. 4 times 1/3, so 2 to the 4/3 power represents this value. Similarly here, 9, we're taking a 5th root, so that's 9 to the 1/5 times 7, 9 to the 7/5. We can move freely between these two representations. So let's give that a shot. Rewriting this expression using a rational exponent. The root is going to be my denominator, the radicand, to a fraction with the root in the denominator, and then my exponent, the 3, can go up on top. So this expression, the 5th root of 2 raised to the 3rd, we rewrite that as 2 to the 3/5 power. How about here, when my exponent, my root rather, is in the denominator of a fraction? Well, remember, that's a negative exponent now. So I have the 5th root of 3, which would be 3 to the 1/5 power. That's in the denominator, so now I'm going to make that negative. 3 to the negative 1/5. If we go the other way, 15 to the 2/3 power. So remember, this is going to be my index, the denominator of my fraction. So I'm right away going to write a radical with that as my index. I'm going to take whatever this is and square it. That's what the numerator of my fraction tells me to do. And then 15 is my radicand. So 15 to the 2/3 power would be written as the cube root of 15 squared. How about here? Okay, so we know that this is going to be a 5th root. We're taking that and we're squaring it, but it's also to the negative 2 power, which means it's going to go in the denominator of a fraction. 1 over the 5th root of 29 squared. The last exercise that we want to be able to do with these rational exponents is to evaluate an expression. If we're given a number raised to a power, in many cases we want to express that in simplest terms. And so I have 25 to the 3/2 power. So remember, this denominator, that's the root. Okay, so this is a square root, and we actually don't write the root that way, but I just did that so that you could see that that was the root. So 25, we're taking that square root and then raising that to the 3rd power. Well, the square root of 25 is 5. So now I'm taking 5 to the 3rd. That value is going to be 125. One more. I have 8 to the negative 5/3. So 8 is my radicand, 3 is my index. The whole thing is being raised to the 5th power, and then it's the denominator of a fraction. So the cube root of 8, what number times itself? 3 times gives me 8 for an answer. That's 2 times 2 times 2. So 2 to the 5th power goes in my denominator. 2 to the 5th is 32. So this is 1 over 32. We'll get a chance to practice all of these skills on the assignment.